Hello and welcome to the newsletter for October 11th. Today we're going to be looking at scaling solutions. And I'm going to go across a whole bunch of different networks. So we'll look at everything from Bitcoin, Ethereum, and even Monero Decred, and just discuss some of the trade-offs and understand a little bit more about what makes each of these scaling solutions tick, how they differ from each other, what are some of the advantages and the disadvantages. And ultimately, with blockchain, because of the way that it is a constrained technology, it does have limits in what it can and can't achieve. And whenever you move in one direction towards, scaling it at a higher level or increasing security, there is a trade-off somewhere along the line. And ultimately, what we're going to end up with, and at least in my view, is long term. There's going to be a mix of different solutions. There'll be a selection of the market that actually utilizes the base layers and that high security, high assurance area, and there'll be upper layers where you can actually ship data and computation and calculations and things in order to basically achieve that scale, but across a number of interconnected layers. Now, some of those will all be built on different, all on Bitcoin. Some of them will be cross-chain solutions. Cross-chain is a whole another kind of topic, and we won't cover that here. But most definitely, when you've got a single architecture, like a single blockchain, we're looking at what can you build on top of that, or what mechanisms exist at the base layer to actually enable greater scalability of what is otherwise a fairly constrained technology. So let's jump right into it. So there's a terminology that goes around called the blockchain trilemma, and we'll get to what those actually are shortly. But essentially, a blockchain itself is a very slow, inefficient, and it's a highly redundant database. It stores data across hundreds to thousands to tens of thousands of computers and nodes, and that data is essentially replicated everywhere. So if one of those particular nodes or instances goes down, you can easily connect into one of the other peers and you'll be able to access it. So it very much functions the same as torrents and things do, where you've got files that are distributed across multiple different systems and multiple different nodes, and it's that high resiliency. And ultimately the question is, when do you need that resiliency? And it's because you don't want someone to shut things down. So ultimately decentralization is part of the mix. And every decision that gets made regarding the actual design of the chain and the way that chain will scale, maintain decentralization, and be secure is there's trade-offs and constraints that revolve around that. And ultimately the dream is all three: the decentralized, the secure, and the scalable. But ultimately it's kind of a pick two, leave one type scenario. It's reality is that you just can't achieve that. And this is where we start entering the world of scalability, where you actually need, in particular, scalability, because decentralized and secure is really what the fundamental purpose of a blockchain is. If you're neither of those two things, if you're neither decentralized or secure, then ultimately you're using a database, and you may as well just use a database. There's very little advantage, and we'll talk about some of the projects that have made this particular trade-off choice, and you'll see there's a bit of a pattern between those. So let's just quickly look at the trade-offs and benefits for each of these three, let's call them pillars or centers towards for the trilemma. So for scalability itself, obviously you're getting speed and user experience. People like things to be confirmed and move on. Ultimately, for the vast majority of people, they're not going to think when you get a confirmation that it's secure or not quite as secure, or finality. They're not going to think about that. They're just going to see it be settled, and they're good to go. For scalability, you can get upgrades and use cases. So when you've got a scalable chain, you tend to have some kind of central planning system. There's a bit more of a centralized infrastructure. It's easier to upgrade the nodes because there's fewer of them. There's things like that allow it to be more feature rich. And more upgrade potential, and lower fees as well, because normally there's trade-offs surrounding the security assumptions to achieve that scalability. And the trade-offs there is that you have reduced decentralization. If you look at something like EOS, which is presumably scalable, but only has 21 validators. You look at some of these centralized coins like the Algorands and the Hashgraphs and things, where it's a handful of nodes, but they get high throughput, and ultimately that introduces a layer of trust. And generally for the scalability type things, if you're doing lots and lots of transactions or lots of complex transactions, which is what that scalability entails, right? Global reach, it's going to be data heavy, and therefore your nodes are over time going to centralize. You're going to get blockchain bloat, and you're going to need increasing data capacity, which Ethereum is currently going through the process of having to deal with. If we look at decentralization, so what you achieve from this is a censorship resistance, so the inability for a government or a centralized entity to basically capture and control it. And because of that, you can impose some kind of credible or sound monetary policy. And the idea here is that the incentives are aligned and the logistical challenge of actually getting in there and changing the node hardware and changing the monetary policy is largely diminished. So it can actually retain, this is why Bitcoin is so decentralized, because it can now retain that sound monetary policy. And there's a fairly good argument to say that we won't see that unpicked or undermined at any point in time. And ultimately, the cost or the trade-off of decentralization is you get speed and efficiency. It's not easy to transport data across a global network of Raspberry Pis. You have that low data capacity. There's only so much validation and processing power involved in that network. And when you are decentralized, you are naturally much slower to upgrade. It is much more challenging to roll out new features. Which for a more scalable blockchain, because it has a trade-off of less decentralization or more centralization, is generally easier to actually roll out those upgrades. So that's that balance between the two. And if we move across to security is kind of an interesting thing because it's also a function of decentralization. These are all a function of each other, and you'll see that a benefit for one is a trade-off in the other. And ultimately, to achieve good security, you need to have an aligned incentive, which means that the chain is going to have some kind of longevity long term, more chance of sticking around and developing Lindy effect. You'll have network reliability because the chain is, it's immutable and it can't be rolled back. And essentially, there's that trust that goes into the network, which is removed. So it creates trust due to the security system. And that's the complete opposite trade-off to scalability, where it's introducing trust in order to achieve that scalability. So security and scalability are pulling at each other in that direction as well. And ultimately, the trade-offs for that is that you're going to have an expensive security budget. In order to maintain high security, you need a clever and well-designed security budget. Now, whether that means you've got infinite inflation, whether it means that you're going to have to rely on a fee market, or some combination of the two. And there is a hardware and energy component to all of that. So, that is the unforgeable side of things. It's why proof of work, in my opinion at least, is the most superior security mechanism, because you cannot forge that security system. There's no way to collude or rewrite history without doing that work. Whereas with proof of stake systems, if you do have enough of an agreement on what the past chain history was, even if it didn't occur, if everybody agrees to it, then it will happen. So, and ultimately with this, you're going to have a reduced feature set, because the more secure it is, complexity is the enemy of security. And when you start introducing complexity in features, you essentially wind down your security layer. So, the security comes from both the hashing rate and the actual network security. But the other layer of it is what is the actual code base? Are there bugs in the code base? How complex is it? How many interoperable functions are there? All that kind of stuff. So security is an all-encompassing system here. And to look at some of the example projects here, so this is kind of the trilemma where, these are the projects that have kind of selected these three different sides. You kind of have to pick a side, right? You pick two different elements that you're going to focus on, two of these trade-offs, and you'll exist somewhere on that trilemma spectrum. So if we start from the left-hand side, in fact, sorry, let's start from the right-hand side, because that's probably the most easy to grasp. You've got the secure and the decentralized. And the trade-off there is that they're going to be slow and inefficient. And ultimately, the best use case for this is sound money, some kind of monetary asset. And, this is really where Bitcoin, Monero, Decred, and to an extent Ethereum actually sit within this realm. It's really what they've focused on. It's been the security element of the decentralization. It has really been their core focus. That's what they're designed to be. They're lightweight clients, and ultimately they are superior at being a sound money. So that's kind of the primary use case of these things. If we roll down to the bottom of this chart, this is looking at scalability and security. Now, it's pretty hard to roll back an EOS node or a Neo node or a Ripple node unless you are Neo, Ripple, or Tron, right, or EOS, one of the 21 or a cartel of them. So if you're you and I, yes, it's very secure. It's very hard for us to unwind anything and change anything, but ultimately they're centralized and fast, right? So they can execute high transaction per second because they have very little network overhead, and they've got a handful of validators that are actually doing the work. And really, I see these as more of it's basically database 2.0. They're good for a distribution mechanism. I can see things like digital securities working on things like this, but really not much else. And to be honest, even these particular projects, as they are, if you're going to have a digital security system, my expectation is it's going to be built, specifically by the banks, like an Omnia type system or something like that. So really, these are just more complex databases, and ultimately, I think that these have a low probability of actually being useful in the future. I think there's going to be far more, ultimately, I think they've missed the point of what blockchains are all about. Although they're good for hype, right? Because they're scalable and fast and move things quickly, and many people are none the wiser. Now, the one on the left-hand side is a little bit more nuanced and complex. So scalable and decentralized. So this doesn't necessarily mean fully decentralized, because you can, even with things like Cardano, there's a central organizing system, right? There's IOHK. Is the main development arm. Tezos is the Tezos Foundation. So there's layers to what you would classify as decentralization. But in all of these things, they have, if you look at Polkadot, they have multiple parachains, right? They've got lots of teams building on. If you look at Horizon, the plan is to build lots of side chains, right? They've got lots of nodes that are implemented. They've got 36,000 nodes or something. So the hardware is decentralized, but that doesn't necessarily mean that the governance is decentralized, and vice versa. You can have, decentralized governance, but, fairly centralized hardware. There's kind of a balance between these things. And often these things, they have some kind of permission security system. And generally they're better at some kind of software platform. They're more of a software system than they are a money. And if I'm going to kind of characterize these things, I've put some notes on the side there. We often see master nodes. Dash would fall into this category. Some kind of master node where, sure, they've got decentralization, but you need to be really, really rich to actually have a stake in that system. They tend to have some kind of centralized governance, Tezos and the like, and Hedera and stuff would kind of sit down the bottom left of this corner. If you're looking at, they've got corporate foundations, Tezos Foundation, Cardano Foundation, Web3, they've got all these different foundations that do this stuff. And quite often proof of stake is the dominant security mechanism. And, if you look at Tezos, they've got bakers, right? You need to have some... you need to have enough money to actually be a baker. It's a semi-permissioned by wealth type system, and that's kind of ultimately the balance here. So they've gone for that increased scalability, and they scale via different mechanisms, but they've got decentralization to some extent. Whether it being community and hardware and governance or some combination of them. But ultimately, there is a degree of permission security, and ultimately, if all of the nodes were to agree on a particular future or past, then that would essentially get rolled into the chain. So it does sacrifice on the security in many layers there, and often it's via not necessarily hash power. Things like governance failure or cartel organization or things like that. So, the security system is essentially undermined because of the ultimate choice or selection process of their of how their governance system and their hardware network is actually laid out. And obviously there's a spectrum between all of these, right? They don't just exist on one of these sides. There's projects that meld in and out of all these different elements. But this is just to give you a bit of a picture on the rough area where I see a lot of these projects sitting and existing. So if we just quickly summarize the scaling design decisions here. So we've got security and decentralized, which is essentially the option there is to go higher. So you create higher layers and side chains, often with reduced assurances, reduced security assumptions, different levels of decentralization. So ultimately the base chain, the L1 chain, is super secure, and then they try to ship data and higher level computation and things higher up the stack, and come back to the main layer for settlement assurances. And Lightning Network is a perfect example of this. If you're looking at scalability and security, so these were kind of the database coins, the Ripples and the Neos of the world. They essentially scale by centralization. They use data centers and central planning systems, and ultimately that is their scaling solution, right? The chain itself is scalable, and you're automatically making the trade-off and the design decision to give up your decentralization layer, right? And what all that means to your transaction finality. And then if we look at scalability and decentralization, that's the software platforms. They're essentially scaling by masternodes. They've got some kind of expensive or permission validation. They make, EOS is kind of that one that's probably trying to blend into that from the the scalability and security into that scalability and decentralization. And obviously, if EOS had 21 nodes at the moment, if they had 50 nodes or 150 nodes or 1,000 nodes, you start shifting further up that decentralization spec because it becomes harder and harder for a centralized cartel to actually capture it. And likewise, if the Tezos Foundation decided to completely disband its foundation and split off into multiple elements, then you would have increasing decentralization over time. But the trade-off would be that it can't adapt as fast, it can't change as quick. There's layers to these things. So that's why it's a bit of a spectrum as things move around. So some of the options that are available for the sound money categories. This is the Bitcoin and Decred-esque type models. So, the Lightning Network is essentially a single settlement in-out transaction. You get near instant payment and finality, and essentially you can have increased functionality. I've seen some people talking about building derivatives markets, futures markets and things on top of Lightning. So it creates a new platform for software development, and ultimately you can bake hundreds to thousands of transactions into a single peg-in, peg-out transaction. So it's using the base layer as a settlement assurance system. So you settle out to Bitcoin layer 1, but you can have many, many transactions. So a single transaction on Bitcoin can represent hundreds, thousands, tens of thousands of Lightning Network transactions. That's the idea of this thing. It's just for settlement at the end of the day. It's basically like settling a bar tab. And the trade-off is that you can have some of these routing nodes centralized. So if, for you and I as users, we don't want to be connecting channels because every channel is an on-chain transaction, and that will obviously create fees and chain bloat. So you and I are better to actually connect our Lightning node to, one of these, what's called a routing node. So just imagine an exchange is a good example, and many of them will be routing nodes. They will set up a Lightning hub. And if you think about Lightning Network like a series of bike spokes that all line up with each other, the routing nodes are at the middle, and the routing nodes all talk to each other. And the idea is that when you connect to a routing node, as long as there's a path via that routing node to your final destination, then your transaction will be able to pass through the network. And the idea of this is that these central routing nodes will essentially be central points where they connect to each other. So that's kind of the large cities. If you think about this as like a city planning system, the routing nodes are your big city centers, and then you've got train networks that run between those. And then in between all of those are the roads that then spit out to individual users, individual businesses. And as long as some path along the rail and the road system can get to your final destination, then your payment can go through. There is an impact on the Bitcoin layer 1 fee market. So, that will obviously take fees away from Bitcoin. And interestingly, so Bitcoin cares about data. So you're moving, your fee is priced in bytes. Whereas Lightning, your fee is based on how much you're sending. So if you're sending $100 or you're sending $10,000, you will pay more fee for the $10,000. So, there's two different fee mechanisms there. And therefore, if you're moving a very, very large amount of value, you actually want to be on the base laying, so it'll be much cheaper for fees. And conversely, which makes sense, right? Higher settlement. And if you're doing a micropayment, then you're better off being on the Lightning Network. So that's kind of this balance between the two. Right now, the user experience is just fundamentally horrible on Lightning Network. It's, even if you've got a nice wallet, the actual pegging in, pegging out, it's going to take some time and work to get that working right. And nodes need to be online. But to be honest, in a lot of instances, if you're talking about mobile payments and things, then everyone's phone is online all the time anyway. So it's really not that big of a deal, I don't think, although it is a trade-off. Things like the liquid sidechains. This is Blockstream's sidechain. You get features like confidential transactions, which would never exist on the base layer of Bitcoin. You can issue assets like securities and shitcoins and tokens and things. And there's a one-to-one peg to BTC. So it ensures that, one BTC equals one BTC. The trade-off is that it's basically a federated or a permission system. It's essentially like a Stellar network built on top of Bitcoin. So you have a bunch of trusted exchanges and trading partners. And, ultimately they have control of it, and there's multi-sigs and things involved. It also impacts the L1 fee market. And ultimately, Blockstream is a profit-motivated actor. And Liquid is there to generate profit for Blockstream, not necessarily to benefit Bitcoin. So there's competing interests in that realm. And then there's things called drive chains and a project called RGB. Now, these are essentially community-led or community-built sidechain projects. And to best describe drive chain, at least, it's essentially altcoins without the altcoin, right? You transfer Bitcoin in, and then you can operate on altcoin type functionality, like smart contracts, and it scales all the data and stuff off chain. But it doesn't need an altcoin, so it's essentially providing additional functionality for Bitcoin without actually needing to create an entirely separate new tradable token. And ultimately, I think this is actually a positive thing. I'd love to see drive chains and an RGB actually get ported over to DCR. I think that would be a really, really exciting development. I think that there's a potential that we can actually push for that. So that'll be an interesting one. The trade-off is that you need long pegging times. So because of the security assumptions, I think it's something on the order of days to weeks. So when you try to peg BTC in, it's going to take a long time for it to actually be confirmed in and out. There needs to be soft forks, which again is why I think Decred is better placed for this than Bitcoin, because no one wants to fork Bitcoin at any point in time, and that soft fork could take years. There's reduced assurances for all of these things, but that's okay. That's kind of expected. And ultimately, they're hard to build and use, especially when you don't have a funding mechanism. What's the incentive to actually build these things? So, ultimately, it's relying on that slow development timeline to build these things out. And interestingly, there is another scalability solution, which is essentially the altcoins with the altcoin. So, this is really what Litecoin has always functioned as. When Bitcoin block space gets full and someone wants to transfer value from one chain to another, from one exchange to another, then they can use Litecoin, right? You buy your LTC, you ship it across, it's high enough liquidity that you're not going to get slapped with slippage. And if you want confidential transactions, then you exchange to Monero, send it via Monero. And Decred is well placed to be one of these alternate altcoins that enables the scalability side of things. But within both of these two projects in particular, Monero and Decred, they've got an interesting set of benefits and trade-offs. So for Monero, they've opted for a tail emission, so that makes their security assumption long-term. They don't have to worry about a fee market as much. And that enables them to deploy something called dynamic block sizes. So whereas Bitcoin has a fixed 1 megabyte block size, and you can only fit so many transactions in, and the highest fee goes first, what Monero has is a system where the miners can opt to increase the block, the actual size of the block, fit more transactions in, but at the expense of the block reward. So ultimately, if there's lots and lots of transactions and the fees that they're paying is going to be more than the block reward itself, then they can basically dump the block reward, increase the block size, and accept all of those transaction fees. And using this is kind of an interesting scaling solution, is it allows miners to basically price and make economic assumptions along the way. So you get consistency in fees, you get longer term security assurances, you don't have to worry about a fee market developing, and you can maintain low fees, which is good for user experience. But the trade-off is that you've got larger blockchain size, you can't prune them as much with Monero's technology. You can't prune and use a shorter blockchain and reduce your data footprint on your machine. And there is a tail issuance in this instance, which on a relative base, if you believe in the 21 million fixed supply and hard money thing, then there is a trade-off there that there's going to be a tail issuance. But again, it's one of those trade-offs that Monero has made, and ultimately it provides a hedge against the 21 million and the fee market actually not developing. And for scalability for DCR, it's essentially gone down the adaptation potential plus the ability to remove technical debt. So because it has the governance system and the ability to evolve and change over time, it can essentially adopt whatever the state-of-the-art technology is. If we come up with new and interesting mechanisms of scaling, then Decred can and will implement it. Because it can hard fork safely, it doesn't have to carry all the old Satoshi code. It can basically clean house and make sure it's a more efficient, clean, and robust and modular code base. So ultimately, when you can optimize to that extent, and nothing is off the table for cleaning, removing, and upgrading, plus you've got the ability to do faster implementations, then you actually create a future scalability solution that we may not know about yet. So it gives it the optionality of evolving over time. And the trade-off there is that you introduce the governance attack vector. So if there's a capture of the proof of stake layer, if there's a capture of the mining layer, or a combination of the two, it's a different trade-off system to what a pure proof of work system has done. And obviously there's complexity here. The more features you add, the more you introduce security risks from bugs and things like that. So it's impossible to write bug-free code. And ultimately that is a trade-off that has to be made and evolved in that sense. But ultimately, these actual altcoins can support Bitcoin, and when fees and stuff get really, really high on Bitcoin, it is possible for people to move value on these high value side chains that can actually retain the same security assumptions and assurances. So there's optionality on that as well. We're going to ignore the scalability solutions for the centralized coins because I don't think there's a great deal of value in talking about those, because essentially they scale via database. But what's more interesting is the software platform type decisions. So for the crypto projects that focus on that smart contract use case, this is generally the process that they go through, and Ethereum has just basically gone through this. They start with smart contracts at the base layer, right? That bootstraps users, it gives people things to do. People write interesting code, and people start doing things, dexes and mixes and all that kind of stuff. And ultimately, you end up with fee congestion and chain bloat. You get a very, very heavy and data, filled chain, and you get fees that essentially build up over time. And that's what we saw with the fee spike in Ethereum of late. And this essentially motivates layer 2 innovation. And usually the governance and security system is centralized, particularly for things like the Polkadots and Cardanos and things. So they can actually make these decisions as they're going and evolve it as time. And the end result generally is a bloated proof of stake layer 1, which then decides, oh, hang on, we're going to go down the layer 2 sidechain route of scaling higher layers. So they almost have to learn the lesson of you can't scale on layer 1, you have to scale on layer 2. But they've done that after they've already reached a bloated base chain, which is kind of where Ethereum is at the moment, and hence the impetus behind ETH2. So two similar designs is the Ethereum 2 sharding proposal and the Polkadot parachain proposal. And the general gist between both of these is that you have the beacon chain in Ethereum, or the relay chain in Polkadot, which is basically a single main proof of stake chain that's all it does. All it does is consensus and look at all the shards that are floating around it, whether it be shards or think about, they're more or less a side chain type system. So you've got the main chain, and it then is looking at all of its side chains that are floating around it. And each of those side chains has a set of validators. In some protocols, for Polkadot, for example, the validators are specific to that particular parachain. For something like Radix, I think, does this as well, and Ethereum 2.0, the idea is that you can have validators which basically move around, and they look at all different shards. And if you've got a pool of 10,000 validators, and you've got let's just say 10 shards, then you're going to have 1,000 validators floating around and moving between each of those. Now, what that means is that you've sacrificed, instead of having a single chain, so if you look at Ethereum as it is today, or Bitcoin today, you have one chain, and every single node is looking at that one chain, right? Hyper secure. If you now move to a sharded blockchain, you're taking that same set of validators, you're chopping them up, and you're distributing them across a whole lot of different side chains. Now, each of those side chains individually is now less secure than the original main chain. The difference is that if one of those side chains goes down, it doesn't necessarily destroy the entire network. So you're kind of splitting up. And I think the best analogy here is that Bitcoin and Ethereum as it is today is more of a series electric circuit. Everything is on the same path. And if you chop off one path, the whole thing shuts down. A sharded or a parachain type solution is essentially a parallel circuit. You've got multiple circuits that can operate independently. If you chop one off, then yes, it impacts some of the other ones, but it doesn't shut them down, right? It just moves some of the validators and the power and things to different areas. So that's kind of the way to think about this, is you're fragmenting up your blockchain into many areas, many subchains, with individually reduced security, but overall you've increased the number of chains that are now independent of each other. So some of the benefits of this is it enables diversity in community and culture. So Polkadot's trying to build each parachain is its own community and design goal and things like that. You've got that enhanced functionality. Each side chain could be doing a completely different thing. There could be some overlap, but you've got resilience to that systemic failure. And it's kind of a theoretical scaling solution. And in theory, you should be able to get lower fees in these type environments, because if we look at the trade-offs, you've essentially diluted your retention, both of validators and so security. So you're splitting your security resources, but you've also split your market participants. So people who are actually using these chains are essentially split across different networks, and you're obviously going to have less attention, therefore less transactions, less fees, all that kind of thing. It does constrain composability. So if you wanted to say take out a loan, if Compound was on a different shard to Maker, and you wanted to take out a Maker loan and then move it into Compound, and they're on a different shard, then in theory you're going to have to wait for multiple confirmations. You have to get a confirmation on the Maker shard, you have to do a confirmation to get across to the Compound shard, and then another one to go into Compound. And ultimately that will create the front running. So we talked about front running the other week. Somebody who exists on the same chain, if you can do the Maker Compound on the same chain, then ultimately you're going to be faster and more efficient than the person who has to go cross-chain. And what that actually creates is an incentive for everyone to be on the one shard. So I'm not really convinced that sharding and parachains are really a good option, because I think the incentive is that nobody wants to be, who wants to build on the network that no one else is on, right? You don't want to go and build on your own thing. You want to build where everyone else is, so you've got composability. And with both of these designs, it introduces immense complexity, which is going to reduce the actual security assurances of the code base itself. So that is a big trade-off that a lot of people don't like to talk about, but it certainly exists. Now, for the primary scaling solutions for Ethereum here at the moment, on the layer 2 side of things, so what we saw there is kind of the chain design, the L1 chain design approach. For Ethereum, the premier scaling solution at the moment that I hear a lot of talk about is called roll-up technology. And what this essentially does is it packages up all the computation. So it is really the I'm not going to say the Lightning Network because it's a little bit different, but the idea is that you package up your complex computations and you ship them off to a separate calculation network. So instead of running that through the Ethereum miners and making them do the processing, what you essentially do is you're batching up a whole lot of calculations into what's called a roll-up, and then you just issue the proof of what the outcome was to the chain. So it's kind of that settlement at the end of the day. You do lots and lots of transactions in one go, and then you post the settlement criteria back to the main chain. And that could contain many, many people's transactions. So you would deposit your funds into some kind of smart contract that now enables it on the roll-up network. You do whatever it is you want to do on the roll-up network, and then there's two different implementations of it at the moment. One's called Optimistic, which allows full EVM, the Ethereum virtual machine. It means you can calculate, you can do any of the smart contracts on Ethereum. It's basically fully compatible. It publishes just the minimum amount of data, and it's called Optimistic because it assumes that there are no frauds being attempted. So ultimately it assumes that everybody is trustworthy. So I think Synthetics is currently operating on this network, and I'll show you a slide of that in a second. And my understanding is because if you trust Synthetics, which is already a semi-centralized system, then you kind of trust their optimistic network, right? It's like trusting a centralized exchange. You assume they're not going to burn their reputation is kind of the nature of this beast. And only when there's somebody who says, hang on a second, that transaction doesn't look valid, that seems wrong, and there's a conflict or a challenge, only then does the rest of the fraud proof need to actually be published. So the idea is that it's supposed to be, it's optimistic because you're trusting the other network, or you're trusting the provider of those calculations that they're not going to be an adverse actor. The other one is called zero knowledge rollup. So this uses zero knowledge proof technology that the likes that Zcash basically developed, and really you can do simple transactions. So you can't do the full EVM. You can't do fancy smart contracts and things. You can do simple transactions. You have a slightly reduced security compared to the main chain, but you have far greater scaling potential than optimistic rollup. So basically, you can put lots and lots of transactions, simple transactions, off chain, and then just ship the final outcome. So this is probably closer to a Lightning Network style scaling solution. So this is just a snapshot from the synthetic staking contract on L2 using Optimistic. More or less, it looks like a blockchain explorer. So ultimately, at the end of the day, they're probably going to settle all of the staking contracts and all the outcome, and they'll send the SNX to everybody who's participated. You can see here that the gas price is 0 Gwei. I think, if I'm not mistaken, Whoever is operating the optimistic side chain or roll-up system, or basically whoever the nodes and validators are, at the moment are basically doing it for free, right? To get people testing it and using it and experimenting with it. I suspect that much like Lightning Network, there will eventually be, the equivalent of routing fees, which will be much cheaper than main chain, but certainly a fee to incentivize people to actually operate these optimistic calculations. No one's just going to run a computer for free. There has to be some kind of incentive. So I think ultimately there will be a gas price here, but I think it's going to remain much, much smaller than what it is on the main chain. And it could be that you have to peg in a certain amount of ETH into a smart contract to then use the optimistic system. So it is similar to the Lightning Network in that respect. And Loopring is a DEX that is, I believe it's a DEX. To be fair, I haven't looked into the trade-off of this particular project, but I know that they are using ZK rollup. So you basically create an account on Loopring, and then ultimately you can trade without gas fees. And I know that IDEX as well. I don't know if they're using ZK rollups, but if you all remember IDEX from back in the the good old days of 2018. They now have some system where you basically just sign a message. Sorry, both of these for Optimistic and ZK. Rather than doing a transaction where you pay a gas fee, you're essentially signing a message, and that signed message is essentially what enables these transactions to go forward. So you don't actually need to pay a gas fee. All you need to do is sign a message on your ledger or whatever, or MetaMask or whatever, and that then enables the trade to go ahead and execute on their end. So to kind of summarize where we're at, the blockchain design trilemma is alive and well, and it's being discovered by different projects at different times in their life cycle. Most notably so, Ethereum has now suddenly realized that, oh boy, financial transactions are going to outprice all of our non-fungible tokens and gaming transactions. And basically, if you're not doing a massive DEX arbitrage, then you're going to be paying a hefty fee relative to the value you're moving around, and it prices people out. Side chains, drive chains, layer 2 scaling, and even centralized exchange crypto banks. They're all inevitable. These things are going to happen. Another scaling solution that we didn't cover here is things like aggregators like Wi-Fi, things like Binance is a scaling solution, Coinbase is a scaling solution. When they start offering staking services and DeFi protocols and all this kind of stuff, you can basically deposit your funds on a centralized exchange, and they batch up and do a whole lot of transactions in one go and represent a much larger pool of people rather than every individual doing it. It's essentially the crypto bank doing it on your behalf. So that is a scaling solution, and one that people often discount as being invalid, but it's most definitely going to be a key part of scaling going forward. And the Bitcoin design ethos of scaling up in layers rather than on the base layer is finally striking Ethereum as a result of that fee pressure and blockchain bloat. And the advent of scaling technology is actually the largest threat in my mind to the deployment of Ethereum 2.0. We talk about this a little bit in this week's Omnia call. And ultimately Ethereum 2.0 is some time away. It's going to take a lot of engineering work to really roll out and get it right. But ultimately, if 1.x, if Ethereum 1 has a proof of work based chain and then some very robust layer 2 scaling solutions, I'm not entirely sure why we need these two. So I think there's going to be a very, very interesting transition period, if at all. We could very well end up with two Ethereums, and I don't know what that's going to do to the market, but I certainly think it's going to be a fragmentation of value. And there's a lot of it's almost a sunk cost fallacy where they've spent all this time and effort and energy shilling and building ETH2, and if it doesn't turn out to be all it cracked up to be, it's going to be a bit hairy. So scaling technology is important, and to be honest, I kind of hope that scaling technology is the way that Ethereum goes, and they kind of drop the whole ETH2 thing. I think it's introducing risk and uncertainty that's just unnecessary. I think they're better to upgrade the proof of work 1 chain. Anyway, that's a bit of an overview. I know there's a lot in there. Scaling is it's a complex problem. There are very few robust information sources on it as yet, particularly on the Ethereum side. I've found that their scaling documentation is all very surface level. It's not very well documented. I get the feeling that's because very few people really understand it. And again, complexity is the enemy of security. I understand the Bitcoin side of things much better because to me it feels more intuitive. But ultimately, all of these systems are shipping data and shipping computation off chain, and then it's essentially a big batching machine. You're batching up transactions at a lower fee, paying the fees to some other group of middlemen, and then deploying just the proof of outcome or proof of result to the main chain for that final settlement. So anyway, it's going to be very interesting to see how this panned out. I don't believe that any scaling technology requires a token. So there could be bull cases where coins appreciate because lots of people are talking about it. I don't necessarily believe that we need tokens to enable scaling. So I would be very cautious of any project that's pitching itself as a scaling solution with a token. The OMG networks of the world. I just don't think you need a token to achieve these things. What they'll pitch is, you need to stake as a validator, like the Chainlink type system, right? You pitch or you stake a bunch of tokens, and that gives you a right to be a validator of it. Anyway, it's certainly an interesting topic. It's going to be an ever-evolving space, and ultimately, all of these projects are facing the same challenge. So it's going to be interesting to see how it all shakes out and plays out in time. I mentioned in this week's Omnia call, so this week, so as in tomorrow for the Monday, I won't be there for the call, but we'll be back to regular programming. So I'll be back on normal time as of next Monday. So until then, I'll catch you then. Cheers.